All right, guys, we're looking at section 6.2. This is May 1st. We're into May already, so we're getting there. You guys in college algebra are kind of short timers. You guys are done on the 22nd, so we're getting there. All right, a couple chapters left. Example 1, we're just trying to look at three equations, three unknowns now. We'll get into it kind of slowly. So use a guess and check method to find 4 points on the plane determined by x plus y plus z equals 6. Honestly, we just got to find three numbers that add up to 6, so one possible solution, 2, 2, 2. How about 3, 4, so that's 7, I need a negative 1, 0, 5, 1. There's an infinite number of possibilities there, you guys. You just need to find three numbers that are going to add up to 6, okay? All right, determine if the ordered triple is a solution. My suggestion to you guys is to use your calculator and use your store features. So, 1 store x, negative 2 store y, and 3 store z. And then you can just put these in. It has to work for all of the equations. So if I put in x plus 4y minus z now, it needs to equal negative 10. 2x plus 5y plus 8z needs to equal 4. So let's just check this one out. So put in a 1, you get a 2 minus 10, which is negative 8, plus 24, that is not 4. So this one doesn't work. If you put those same values into here, it turns out that that one does. And you just need to test them for all three equations. If they work for all three, you're good to go. Okay? So we've seen this from section 1, so operations that produce equivalent systems. You could change the order of the equations, you can replace an equation by a non-zero constant, multiple of that equation, so you can multiply a row by something. You can replace an equation with the sum of two equations, and we're going to do that a little bit here as we go. So if I want to solve a system of three equations and three unknowns, get them in standard form, so you got the x's, the y's, and the z's all lined up. If the x term in any equation has a coefficient of 1, put that equation first. Use the x term in R1 to eliminate R2 and R3. So we're trying to get rid of the x's so that we just have two equations and two unknowns, which after last section we should be pretty good at. And then we can use substitution to go back and solve. Okay, so my suggestion to you guys here is there's your x that is a 1. So I'm going to rewrite this as such. So I'm going to put that first. Okay. I can take that first one and rewrite it. And then we'll put that one third. Negative 2y minus z equals negative 3. Okay. So I've done their first step. I've gotten that x out in front. And this third equation doesn't have an x, so I just need to eliminate x one time. So I'm going to take negative 2 times row 1, and I'm going to add it to row 2. Okay, so negative 2 plus 2, I'm going to eliminate x again. So I'm going to leave the first equation alone. And then I'm going to reevaluate the second equation using this rule. So negative 2 plus 2, the x's are gone. Negative 2 times y is negative 2 plus 1 is negative y. Okay, and negative 2 plus negative 2 is minus 4z. And negative 2 times negative 1 is 2 plus negative 7 is negative 5. And I'm going to leave the third equation alone. Okay, so now I've got a new system to work with, and you'll notice I don't have x's anymore. So I can just focus on that system right there. Okay, so I'm going to multiply this row by negative 2 so that I get the y's to be the same. Okay, so that's going to give me 2y plus 8z equals 10. We'll leave the second equation alone. Okay, and now since the y's are the same, we're going to add these two equations together. So 2y negative 2y is nothing, 8z minus z is 7z, 10 plus negative 3 is 7. So I know now that z equals 1, okay? And so when we start looking at our solution, I know z is 1. And then I'm going to start just back substituting. If z is 1, let's go ahead and put that in here. So 8 times 1 is 8. Subtract the 8, you get a 2 divided by 2. Turns out y is 1 as well, okay? And then I got to go back to one of the first equations. So let's just take this one right here. Put in a 1 for y and z. So 1 plus 1 is 2. I got to subtract a 2. Negative 1 minus 2 is negative 3. And just like we did on the second example, check it, put it back into all three equations and make sure it works. All right, so that's an example of how we're going to do this. We're going to just see more examples of this as we go here. Example 4. Okay, these are kind of all jarbled in different orders, so I'm going to need to rewrite so that I get them in the right order. I notice that x right here has a 1 out in front, so I'm going to write this one first. X plus 3y minus z equals 5, okay? And then I can write these next. So this would be 2x minus 5y minus z equals negative 8. And then this equation here, negative x plus 3z plus, whoops, sorry. Okay, and so negative x plus 2y, I got to get them in the right order here, plus 3z equals 13. Okay, so I've rewritten our system so that I've got a 1 out in front there, which is what I was hoping for. Okay, and then we're going to do what we did before. So we're going to take negative 2 times row 1 and we're going to add it to row 2, because that'll give me negative 2 plus 2, that'll eliminate my x's. And then I'm going to just add row 1 and row 3 together, because that will eliminate the x's there. Okay, so I'm going to leave the first row alone. And then I'm going to apply these rules. So negative 2 plus 2, that gives me no x's. Negative 6 plus negative 5 is negative 11y. Negative 1 times negative 2 is 2, plus negative 1 is z. And negative 10 plus negative 8 is negative 18. Okay? And then this one, I'm going to just add row 1 and row 3 together and then replace. So 1 plus negative 1 is nothing. 3 plus 2 is 5y. Negative 1 plus 3 is 2z. Okay? And negative 8 plus, or 5 plus 13 is 18. Okay, so now if I look at these two, I've eliminated my x's, and so I can figure out a way to just determine this. So let's multiply the first row by negative 2 and rewrite so that my z's are the same. So this is going to be 22y minus 2z equals 36. And then we're going to leave the second row alone. Okay, if I add these together, I get 27y equals 54. Divide by 27, and I know y has to be 2. Okay? All right, now I can back substitute. If y is 2, I'll put a 2 in right here. 5 times 2 is 10. Subtract 10, I get 8 over here. 8 divided by 2 is 4 for z. And you can work this out algebraically. I'm doing this in my head, but you can actually go 5 times 2 plus 2z equals 18 and just solve it, okay? And then I got to back substitute to maybe the first equation here. If I put a 2 in here, I get a 6. Minus 4 is 2, so I have to subtract 2 from 5 and I get 3 for x. So 3, 2, 4. Again, check them out. Put them back into the original equation and make sure they work, okay? All right. Similar situation here, you guys. I'm going to try to set it up so that we can make this work. I notice I don't have any 1's out in front of the x's, but I do have a 1 out in front of the y. So I'm going to eliminate my y's initially, okay? So I'm going to go let's write it here. I'm gonna go 2 times row 1 plus row 2. And then I'm gonna just take negative 2 times row 1 plus row 3, okay? Because I want those y's to be gone. So I'm gonna leave the first one the same. Okay, then let's apply this rule. 2 times the first row plus the second row. So 4 plus 3 is 7x, okay? And then 2 plus negative 2, my y's are gone, that's what I was hoping to get. Negative 6 plus 4 is minus 2z. And then negative 6 plus 2 is negative 4 on the right side, okay? Now we're going to apply this rule. So we're going to multiply the first row by negative 2 and then add the third row. So negative 4 plus 4, that's 0. Negative 2 plus 2, that's 0 again. 6 plus negative 6, that's 0 on the left side, okay? On the right side, I get 6 plus negative 7, I get negative 1. Now, when your variables completely fall off, you have one of two scenarios here, guys. You have either no solution or infinitely many solutions. And we saw this in the last slide, or the last section, 6.1. Here, 0 doesn't equal negative 1, so no solution or the empty set. Either way you want to look at that is how we're going to get that. You don't know that to begin with. You actually have to start the process. But once you get to the point where you've eliminated the variables and what you have is not true, you're pretty well done now. Okay? All right. So now you'll notice I've got 3 unknowns, but only 2 equations. So I'm not going to be able to get one specific solution. There's going to be an infinite number here, and I'm going to have to write a blueprint for how I do it. Okay? I can make my life a little bit easier. Okay? I notice that the y's are already the same number, so I'm going to add these together, and I'm going to get x, add these up, I get minus z equals negative 4. Okay, that's going to make my life just a little bit easier. What I can do, it should be pretty easy to solve for x here. So here's what you're going to do. You got to write a blueprint. So you got to pick one of the letters to solve for in terms of each time. So I'm just going to say, let's let z be z this time. And I might, the last time I did this with you, I let x be x. I'm just going to let z be z. If I solve for x right here, okay, I'm going to get x equals z minus 4. So my x term over here, we're going to put z minus 4, okay? Now, I got to go back to one of these equations and I need to solve for y. So x was z minus 4, so 2 times z minus 4, plus 5y, minus 3z, equals negative 5. Okay, and my only goal here is to solve for y in terms of z. So I'm going to distribute here. So this is 2z minus 8 plus 5y minus 3z equals negative 5. I can simplify the left side a little bit. 2z minus 3z is negative z. Minus 8 plus 5y equals negative 5. Okay, let's move some stuff over. So 5y, let's add the 8. And I'm going to get a 3. Add the z. I get z plus 3, right? And now if I divide by 5, I'm going to get some fractions. So I'm going to get 1/5 z plus 3/5. And that's going to be my solution then, guys. So there's infinitely many solutions, and that is an example of a blueprint that will work for it. Okay, so if I pick a z, say 7, I can go ahead and put a 7 in there, and I'll have a solution that will work. Okay? All right. Let's look at example 7. Solve using elimination. Okay? So I've noticed this particular equation right here doesn't have a z. So if I start by just adding row 1 and row 2 together, I'm going to eliminate the z there. Okay? So let's see what we've got. We've got 3x minus 2y plus z equals negative 1. And then if I add row 1 and row 2, that gives me 5x, negative 2y plus y is minus y. The z's are gone, and I get 4. And then that last equation will just leave 10x minus 2y equals 8. Okay? Now, if I look at those equations, they don't have z's, so I can just try to solve using elimination. I'm going to multiply this row by negative 2. Okay, so I'm going to come over here. That's going to give me negative 10x plus 2y equals negative 8. And then the second row is 10x minus 2y equals 8. And when I add these together, I get 0 equals 0. Okay? Well, what does that mean, you guys? That means that there's an infinite number of solutions and I need to come up with a blueprint for them. This time for my blueprint, I'm going to let x equal x, and I'm going to try to solve the others in terms of that. Okay? So, if I take this 5x minus y equals 4, I'll move it up here. And I solve for y. Divide by the negative 1, and I get 5x minus 4. Okay? So that's going to be my y term here, 5x minus 4. And then I got to solve for z in one of these equations. So let's take this second one here. That looks pretty simple. So 2x plus y, which we said was 5x minus 4, minus z equals 5. Okay? And I'm going to try to get z by itself here. So this is 7x minus 4 minus z equals 5. Okay? So add the 4 and subtract the 7x. So that'd be negative 7x plus 9. Okay? Now, if I divide by this negative out in front, I'm going to get then 7x minus 9. And again, I then have a blueprint for solving it. I know there's an infinite number of solutions, but if I want a solution, I can now pick an x, say 8, and put it in there and get an ordered triple that will work. Okay? All right, one more example, you guys, and then we'll go through and get some homework. So, small business borrowed $225,000 from 3 different lenders to expand their product line. The interest rates were 5%, 6%, 7%. Find how much was borrowed at each rate if the annual interest came to $13,000, and twice as much was borrowed at the 5% than was borrowed at the 7%. So the first thing I need to do with this one is I need to come up with a system of equations. So I'm going to let x be the amount I borrowed at 5%, y be the amount I borrowed at 6%, and z be the amount I borrowed at 7%. So just to remind us, I'll put those right here, okay? So I know I borrowed a total of $225,000, so I'll write this up here. So x plus y plus z is $225,000. And I know that I made $13,000 interest. Well, I take interest, simple interest, just by multiplying by the percentage. So this is going to be 0.05x plus 0.06y plus 0.07z equals that 13,000. Okay, whoops, extra 0. Okay. And we borrowed twice as much at 5% than we did at 7%. So that's going to be x equals 2z, which means x minus 2z equals 0. Okay? And once you have your system, you guys, it's not going to be super hard to solve this. It's the same process that we've been doing before. You'll notice I don't have a y term. So if I were to take 0.06 times row 1, that would give me 0.0, and minus row 2, I would eliminate the y in one of those equations. So I'm going to do that, you guys. So I'm going to leave the first one alone. X plus y plus z equals 225,000. Okay? And when I apply this rule, so 0.06 minus 0.05 is 0.01. 0.06 minus 0.06 is nothing, that's why I did it. 0.06 minus 0.07 is minus 0.01. And if I take 0.06 times 225,000 minus 13,000, I get 500. Okay? And then of course I have the x. Okay? Minus the 2z equals 0 that I can work with. Okay, so now if I just focus on those two equations, I can multiply the second equation by 0.01. So then I've got the first equation up here, 0.01x minus 0.01z equals 500. Multiply the second equation by 0.01. Okay, and then I can subtract these. Those are gone. Negative, or 0.01 minus 0.01 minus a negative 0.01 is 0.01z equals 500. Okay, divide, and z is going to be $50,000. So I know I invested $50,000 at z, and then I just need to back substitute a little bit. So if I put a 50,000 in here, 2 times 50,000 is 100,000, so x must be 100,000. Okay? And y, well, all three of them have to add up to 225,000. So you add these up, you get 150,000. That leaves 75,000 for y. Okay? And I think we're going to leave it there, you guys. Okay? So I'm going to just move on here to the exact. I'm going to switch the assignment up a little bit on you guys. Okay? So what I want you to do here is on page 529, you're going to do 6 to 24 multiples of 3. That's fine. And let's cross that part out. We're going to do numbers 25, 29, 33, 37, 43, 47, and 51. I think that's what I want. 25, 29, 33, 37, 43. Yep. So that's what I'm going to have you guys do. Any questions? Please ask, okay? Good luck.